Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from definite integrals involving greatest integer function, right? So here we have to evaluate this integral from 0 to square root of 2 tan inverse, and we have greatest integer of 1 minus x square, right? So here we see that our integrand is tan inverse greatest integer of 1 minus x square, right? So what we will do, we'll solve these type of problems by method of substitution, right? So let us call this integral as I, right? So what we will do, we'll take 1 minus x square as t, right? So let t is equal to 1 minus x square, so that x square is equal to 1 minus t, and x can be written as square root of 1 minus t, right? Okay, so now the relation between x and t is x is equal to square root of 1 minus t. Now let us differentiate both sides with respect to t, right? So dx over dt is the derivative of square root of 1 minus t, and the derivative of square root of 1 minus t is minus half, and we have square root of 1 minus t, right? So dx over dt is equal to minus 1 over 2 times square root of 1 minus t. So dx can be written as minus dt over 2 times square root of 1 minus t, right? So here what we have used this fact, that is the derivative of square root of x is 1 over 2 times square root of x, and then by chain rule the derivative of 1 minus t is minus 1, right? Okay, so we have the expression for dx in terms of t. Now let us change the limits, right? So here x varies from 0 to x is equal to square root of 2, right? So when x is equal to 0, we can find out the value of t from this expression. So we have t is equal to 1 minus 0 square, that is simply 1, and when x is equal to square root of 2, then t is 1 minus square root of 2, and here we have a square, right? So this is equal to 1 minus 2, that is equal to minus 1, right? So when x varies from 0 to square root of 2, t varies from 1 to minus 1, right? So now we can write our integral I as 1 to minus 1, and we have tan inverse, and for greatest integer of 1 minus x square we can write t. So here we have greatest integer of t, right? And for dx we can write here minus dt over 2 times square root of 1 minus t, right? So now we can rearrange this integral by taking half outside the integral, and here we have the negative sign. So in order to neutralize this negative sign, we can reverse the limits. So here we have minus 1 to 1, that is we can interchange the limits by eliminating this negative sign. So we have tan inverse of square root of t, greatest integer of t, divided by square root of 1 minus t, right? So here we have used this property, that is if we have a to b f of t dt, then if we interchange the limits we can put a negative sign before the integral, right? So we have b to a, and we have f of t dt, right? So now we have to solve this integral. So now viewers, see, we have to solve this integral. So here we see that the limits of integration are from minus 1 to 1, right? So if we represent these two limits on the number line, here we have minus 1 and here we have 1, right? And between minus 1 and 1 we have the integer 0, right? So what we will do, we'll break this integral as a sum of two integrals, right? Because here we have the greatest integer function, and while dealing with the greatest integer function, we have to search for integers, right? So the lower limit is -1 and the upper limit is 1, right? And between -1 and 1 we have the integer 0. So this integral can now be written as from -1 to 0 and then from 0 to 1, right? So now we can write I is equal to half, and we have the first integral from -1 to 0, tan inverse of greatest integer of t over square root of 1 minus t dt, and then we have 0 to 1 and tan inverse greatest integer of t divided by square root of 1 minus t, right? Okay, so now we have these two integrals, right? Now see, let us first take this integral. Now we can take this integral as I1, this integral as I2. So now I can be written as half times I1 plus I2, right? So now we'll separately solve I1 and I2. So now let us first take I1, right? Now see, I1 is from -1 to 0 tan inverse greatest integer of t divided by square root of 1 minus t dt, and see here t varies from -1 to 0, right? So the limits of integration are from -1 to 0. So t lies between -1 and 0, and whenever t lies between -1 and 0, then the greatest integer of t is equal to -1, right? So here for greatest integer of t, we can write -1. So now this integral reads as -1 to 0. We have tan inverse of -1, and here we have square root of 1 minus t dt, right? And we know that the value of tan inverse of -1 is minus pi by 4, right? So now here we can write -1 to 0, we have minus pi by 4, and square root of 1 minus t dt, and we can now take this minus pi by 4 outside the integral because it is a constant. So we have this expression, right? Okay, so now we have to find the value of this integral, right? So again we'll make use of the method of substitution, and what we will do, we'll take 1 minus t as u, right? So we'll take 1 minus t as u, so du is equal to minus dt, so dt is equal to minus du, and the limits of integration can be changed accordingly. So when t is -1, then u is equal to 1 minus -1, so this is 1 plus 1, that is 2, right? And when t is 0, u is equal to 1 minus 0, that is 1, right? So now I1 can be written as minus pi by 4, and we have -1 to 0. So here we have 2 to 1, we have 2 to 1, and for dt we can write minus du, and here we have square root of u, right? So now we can write the value of I1 as see, this negative sign and this negative sign becomes positive, so we have pi by 4, and we have 2 to 1, and we have u raised to minus half du, right? And we know from indefinite integrals, that is the integral of x raised to n is x raised to n plus 1 over n plus 1, provided n is not equal to -1, right? So here the value of n is minus half, so we have I1 is equal to pi by 4, and we have u raised to minus half plus 1 divided by minus half plus 1, and the limits are from 2 to 1, and here we have pi by 4, Minus half plus 1 is half, so we can take 2 in the numerator, and here we have u raised to half, and limits are from 2 to 1, so this is pi over 2. And when we take 1 the limits here and we'll take the difference, so we have 1 raised to half minus 2 raised to half, right? So this is pi over 2, and 1 raised to half is 1, this is square root of 2, right? So viewers, the value of this integral, that is I1, is given by pi by 2 times 1 minus square root of 2, right? Now let us find the value of I2. So now I2 is equal to 0 to 1, and here we have tan inverse greatest integer of t divided by square root of 1 minus t dt, right? Okay, now see here we observe that the limits of integration are from 0 to 1, right? So our t, it lies between 0 and 1, right? So when t lies between 0 and 1, then by the definition of greatest integer function, the value of greatest integer of t is always equal to 0, right? So it means we have tan inverse of 0 for greatest integer of t, we can write 0, right? So here we have 0, and here we have square root of 1 minus t and dt, right? And see, tan inverse of 0 is equal to 0, right? So the integral here it disappears, or the value of this integral becomes 0, right? So I2 is equal to 0, and I1 is given by this expression, right? So our I is half, and we'll write here pi by 2, then we have 1 minus square root of 2 plus the value of I2 is 0, and now we can write pi by 4, and here we have 1 minus square root of 2, right? So viewers, the value of this integral is equal to pi by 4 times 1 minus square root of 2.